So welcome to this live Q&A event for the Boiler Control 284. The intent for this presentation is to answer any questions that you may have after watching the technical webinar or even after selling or supporting the Boiler Control 284 directly. So we wanted to receive some questions via email to start off this presentation, and we got one. Thank you, Dave Eberhardt. So we'll start off with that email question, and then we will ask some of the questions that we developed ourselves, and then we'll open it up to any live questions that you may have. So the first question that we received was, why did we redefine what are traditionally called secondary pumps or boiler system pumps as primary pumps for the 284? So I'll let Jason, who is the product expert for the 284, answer that question.
Yeah, so one thing we looked at, especially with this 284, is that we were trying to introduce new terminology. If you actually recall, we have like near boiler piping, and we have system loop piping, and with the presence of new sensors and control of different pumps, we thought what would be the best way to transition moving forward, considering future products. So, and if you recall though, if you look at say the 275, even though in our terminology we may have described it as system pump, if you actually look at the actual labeling, some of the controls, it actually is primary pump. So you want to be consistent with actually not only how we label it on the control, on the Lexan, but also through training material, and also just, again, just moving forward considering new products. So now, if you look at the 284, we call, of course, the boiler pumps. So all within the boiler, we have full control of the boiler pumps. We call them boiler pumps. Then we have sensors attached in the boiler loop piping, such as boiler outlet sensor, boiler inlet sensor. Then we have in the system loop, and if you guys can see we as well, we have, we'll just show you here, this application drawn here. So if we look in the actual boiler loop right there, so that's, we call that now the boiler loop. So the boiler pumps P3 through P6 plus the respective optional outlet sensors, so S6 through S9. Then the inlet sensor. So that whole loop is the near boiler piping. Then if we move over to the secondary loop, the system loop, now we have the primary pumps, which is P1, P2. So now we're going to call that the primary pump as opposed to system pump. And then same thing with the actual sensors. So system supply and then the system return. So yeah, we just want to be now consistent moving forward as far as terminology and how we define the loops and plus the pumps which are contained in that loop.
Yeah, I was just worried that, primary pumps have been called primary pumps for 50 years.
Yep.
And now we're changing them.
Well,
I talked to 90% of my engineers, because I'm doing education, that's going to be something totally different. They're going to have to change opposite what they're used to calling things.
Well, in this case, so just to be clear, though, maybe I misunderstood the question, but if you look at P1 and P2, those have always been called primary pumps, right?
Well, but they haven't by the industry. That's what I'm saying.
What's the industry call them?
Well, if you ever been to any, Bell and Gossett stuff, and maybe I'm a little unusual that I'm a B&G guy. P, in this diagram, we're looking at 3, 4, 5, and 6 are primary pumps. And P1 and 2 would be secondary pumps, and P7 or 8 would be zone pumps. So if you look at any of the documentation, now Dan Holohan calls them something else. Well, he usually, and John Siegenthaler calls them something else.
Right.
And Tekmar calls them something else.
Yeah, so I guess trying to find that gimlet, you're never going to, I guess, appease everyone, right? So, but in that regard, though, we haven't really changed that terminology because we've always called, the primary pumps. That has always been the case. The same thing with the boiler pumps, which you're calling primary pumps. So I guess, it's nice to be consistent, but at the same time, there's different terminology based on different standards and different manufacturers. So
we just think of it as B&G, I guess, because they invented it. So.
Right. Yeah. Okay.
But I guess as long as it's just going to be confusing, that's all. When we're diagnosing on the phone, it'll be easy if you're looking at a piping diagram and putting your finger on it.
Right,
It can be hard over the phone because someone's going to call them the primary pumps just because they have for 50 years. So we'll just have to clarify.
Yeah. Okay. Okay.
All right, so we'll move to our next question. And this is a question that we've actually gotten in our customer support center a few times, which is, can we control thermostats through the BAS? So I'll let Jason answer that.
Well, before I answer that question, let's just first, I want to just define, maybe this is a better question to answer first. As far as on the BAS side, now if we look at, this is of course brand new for us, this is a new market segment for us. So again, BAS standing for Building Automation System, which means we natively support a protocol which includes Modbus and then of course BACnet over IP, which of course allows us to now communicate with a building automation network. So now we can basically allow for certain parameters to be written and also read. Now the question is, which Elizabeth just asked, is if you hook up a Tecmar Net4 system, are you able to provide a message set of our thermostats, for example, over the BAS network? Anyone want to take a shot at that question?
No.
No, that's right. No.
Yeah, because we don't talk to TN4 or TN2.
That's right. So
language
yeah,
on the same network.
Yeah.
So BAS is just monitoring or controlling the boiler.
That's right. Yeah. So basically, if that's something we choose down the road, we'd have to basically develop a gateway, Tecmar Net4 to the appropriate protocol. So that, but as it stands right now, we can't display anything to do with Tecmar Net4 and provide a message set over to the BAS. And you can see that too. If you guys have had a chance to look through the literature, what's available to be read and of course written from the 284 over to the BAS, you can see that. But it does not include TN4.
Very good.
Okay.
All right, our next question. Can we connect the 284 to a 423 for multiple boiler staging?
Now let me ask, and I'll ask you a question before that as well. Here, when would you do that first off? So if you had a 284, when would you think you'd connect that up to a 423?
If we had
multiple
water temperatures with 4 boilers.
Well, yeah, the key thing there is, of course, if you just had one temperature, there's no reason why you'd connect a 423 to a 284, right? Just use a 284 by itself. If you have more than one temperature, because of course the 284 only supports one Tecmar Net4 temperature, right? So even though it supports 4 buses, those buses are for the purpose of supporting up to 96 zones, but it's still defined as one boiler reset temperature. So if you have, say, staple up and inflow radiant, so forth, then yeah, you'd maybe hook up a 423 or even like say a 402, for example, right? And you could basically just then use the Tecmar stager function, right, where you basically select a switch, say in the 423, and then we have dedicated terminals which would wire into terminals 16, EMS input, and 19, common. So now what the 423, for example, is going to provide a target temperature to the 284. We'll in turn interpret that as the target temperature and operate the plant to maintain that respective temperature. So it's no different than what you do with, say, a 423 with, say, 275 or 274. The same idea.
So let me get just a little clarification on that, Jason.
Yep.
So I put this on the gateway. I'm only going to see the 423 or the 402 because this is not going to be on the gateway because we can only have one control on the gateway.
That is correct. Yes. Yeah.
Okay.
Yeah. So yeah, if you had in that case there, just for everyone here who just wants to make sure that's clear, if you had say a 423 given a 0-10 volt signal to the 284 and you want to hook up a gateway, you'd have to choose one or the other. You could do both, right? You could have 2 different independent gateways with 2 independent Mac Minis, for example. But yeah, it does not. There's no link between the 284 and the 423 as far as Tecmar Net4 is concerned.
I'm confused again. This is Dave again. So the basic question is it only supports one temperature, and
That's
you can
correct.
choose which one you're looking at. But we would still be able to run a separate controller, say a motorized three-way valve, to maintain a lower temperature. It just isn't visible to
Correct.
the building.
That's
so
correct.
It's a little bit like running like the mix we used to have before, when we'd have a motorized mixing valve, and if we were running another temperature, we'd use, say, a thermostatic mixing valve, like a set point control on that lower temperature. Mm-hmm. We know it's controlling it, we just can't see it.
Right. So in this case, let's just say someone wants to see, for example, let's just say they want to see the thermostats connected to their mixing system. So they have a 423, right? Say they have a couple mixing valves, and they have, say, 20 zones, right? So they actually want to see that information on the gateway, right? But let's just say they have 3 boilers. So they buy the 284. So they hook the 284, sorry, the 423 up to the 284 via the EMS input in the 284. Then they would connect up the gateway to the actual 423, right? So now all the information which is connected to the 423 will be accessed and displayed on the web-based gateway. The 284 information, however, is not going to be displayed on the gateway.
Could we trick it, though, if we used another, we can look at, this is the wrong slide, but there's another slide where we look at various temperature inputs, like for pressure inputs or temperature inputs. Or
right.
Could we bring a temperature in to make that visible from one of those other temperature sensor inputs if we came off that separate temperature loop?
Well, and again, anything which is connected directly to the 284, okay. If you want to display that on the gateway, right, it'd have to be an independent gateway.
Right, but it would be still coming into the 284. It would just be coming into a place it wasn't expecting to see it.
Yes.
Because we're looking at, we have multiple sensor inputs, S1 through 7.
That's correct.
So
yes.
I'm just saying, if we brought that temperature, we wouldn't be controlling it, but maybe it would be visible if we brought it in through another temperature sensor input.
Another temperature sensor input?
Well, if we're not using all the boilers, all the temperature sensors,
yes,
1 through 7,
right?
We're not using all.
Okay, you're not using them, okay.
What if we decided to use one of them for that low temperature that we wanted just to make visible on the BAS? That way it would be still coming into the 284.
Okay, I'm kind of like mixing things here. Now you're referring to BAS, right? So,
well, I'm talking about we have a 2-temperature system now.
Yes.
We have one temperature that we're controlling to, and then we have another temperature that we can't see, but it's being blended by something. And we take one of those sensor inputs that we're not using the control to for our 284. That might be 7, I'll just say. Could we would that then make that temperature visible to it would make it visible to the 284. Would that also make it visible to the BAS?
No. No, it would not.
Okay.
How about to the gateway?
No.
You understand what I'm asking, right?
I understand what you're asking, yeah. So let's say you weren't using a vent sensor.
Right.
Could you attach a sensor there? Even though it's not a vent sensor, maybe it's, a mixed supply sensor.
Right.
Could it show up on the gateway? It would still show up as vent sensor, but really it's mixed supply.
Yeah, that's why, again, making sure that, if you have, because I'm just saying again, if you have the gateway connected to, say, the 423 in this case, right?
Well,
if that was my example, right? So if it was connected to the 423, yes, it'll show up on the 284. Let's just say it's a mixed sensor or something else, right, which is not really operational. It'll show on the 284. Now the question is, what do you want to do with it now? So if you want to,
well, we just want BAS. Somebody wants to look at it. Let's say.
Sure. Oh yeah. In that case, there, let's just say you hooked up a gateway to the 284 or back to a Modbus, right?
Right.
And by all means, it'll show it there. It'll show it as vent in this case, but it won't do anything.
Mm-hmm. Yeah, so it's almost like we call it something, but it's almost like a configured setting. maybe if you were worried about boiler room temperature. You know, I don't know why you would be, but air temperature in the boiler room.
Sure,
you could still make that visible. It's almost like we call it vent or whatever, but it's almost like a configurable setting.
Yeah, but you just can't configure it to be generic. It'll be event. What you would do though in that case, just because there's operation tied, and that's probably where you best tie it into. If you tied into vent, there's a setting called like vent max, where there actually was logic imposed to it. But if you turn it to off, then all it does is display, and you could do that for So you could say, hey, hook up your indoor sensor to the vent, and that's mounted in your mechanical room. And it'll display it, and there you go.
Okay.
Yeah.
Cool.
Yeah. Then of course, if you have a gateway connected to it or BAS, then of course it will display that on the remote network.
Yeah. That might be interesting.
Yeah.
Now, will the pressure sensor and flow sensor information show up on the gateway?
Yes, if there's a gateway connected, Okay.
All right, so our next question, another BAS question, is what protocols does the 284 support for BAS?
Anyone want to take I think I mentioned that like probably 10 minutes ago, but anyone?
Yeah, that's BACnet or Modbus.
Right, and just to clarify, because there are different protocols out there, and Modbus is probably one of the older ones, and so it's Modbus, and the physical layer for Modbus is basically uses like an RS-45 circuit, and that's typical in old buildings, Modbus. But if you look at anything new, and this is just figures that I've come up with based on my research, probably I think about 75% of the applications now, they use, I think, BACnet, but it's BACnet MSTP, which means Master-Slave Token Passing, and that works off a physical layer of RS-45 as well. But anything new which is going in, it's very easy to integrate. It's BACnet IP, which uses an Ethernet jack. Okay, but as far as what the 284 supports, it's basically, again, it's Modbus, which uses RS-45, and we support two types, whether it's RTU, which means Remote Terminal Unit, or it's the ASCII. And then on the BACnet side, of course, it's IP. So we support one or the other. You basically select what protocol you want to use. Any questions on that, or?
Is there another common language out there that they use?
There is. If you look at, there's other protocols out there. Like for example, I do know like in a lot of where extra security is required, such as say military bases, things like that. I know that LawnWorks, that's popular. Yeah.
Now there's
Siemens N2 also.
Pardon me?
Siemens N2 is a company.
Oh yeah, N2. Yeah, there's the Metasys, and there's different protocols out there. But there are
a lot of these guys you can translate from BACnet to that.
That's correct. Yeah, you can actually there are third-party devices out there which you can buy a gateway, such as Field Server. They make these third-party gateways, so they'll take information from one protocol and communicate out to a different protocol. Yeah, so if you, let's just say when your customer is working on a job and hey, they require, say Lawn Talk, for example, then you can purchase, for example, a Field Server gateway aftermarket and then integrate it with this.
That answers the question.
Okay. Any other questions on building automation systems?
Okay. So another question I have here is, can you explain how the boiler lead group priority can change?
Now, do you guys, first off, do you know what we're talking about there when we say the boiler lead group priority? We're talking about the mixed plant operation.
Yep.
Right? So, and that's one of the new features we're talking about with, with this control here, where we have a hybrid or a mixed plant where you may have, say, a condensing group and a non-condensing group. Now, the question is, when would this come up? Right? So when would you have an application where you would have, for example, a condensing and non-condensing? Well, it might be retrofit. Maybe it's new construction. They want to save some money, so they, hey, you know what? I'll put in like say a Category 4 non-condensing boiler, which can achieve, 87 plus efficiency, and they can use that and combine it with, say, some condensing boilers. So they can save significant costs, capital costs to do that. So the question is, okay, well now how would you want to operate that? Appreciating that, obviously with the temperature, when it goes up, the supply temperature on a condensing boiler, the efficiency goes down, right? So how can we capitalize on the benefits of each, right? So realizing that, okay, well this is a non-condensing boiler and this is a condensing boiler. So what happens now is with our control, in this case here, as soon as you select the type of boiler you have, right, so it'll actually have a type. Is it condensing or is it non-condensing? So as soon as you have two different types of boilers, it now has this lead group setting, which says, okay, how do you want to lead? So now here you have like two sets, like say two boilers which are non-condensing, two which are condensing. And again, as soon as you select one which is non-condensing, you'll get a boiler minimum setting, which essentially is your changeover point. So basically what happens there is whenever the actual calculated target temperature, okay, is below the that boiler minimum standpoint, in this case we'll just choose 140, it's going to lead with the actual condensing group. Okay. Then as your heat loss increases, gets colder outside, now then once your actual target temperature, calculated target temperature, is at least that boiler minimum, it's going to lead with the non-condensing group. So that's that changeover point. You get to choose that, by the way. So again, you can always say the lead is always the condensing, regardless of the actual calculated boiler minimum, or you can have it choose it based on what the actual boiler minimum is. Okay. So that's just to capture the point there too as well. If we looked at the on the 275, is we did enhance that operation at one point where we supported this mixed plant, but with the 275, you don't get this selection. It always leads with the condensing group, always. Again, with this, you get to choose. If you want it to choose based on the priority setting, that means, again, it will basically lead with the condensing group. When that calculated target is below the boiler minimum of the non-condensing group, then as you need more capacity, it will then bring on the non-condensing group. And as soon as the calculated target is above that boiler minimum of the non-condensing group, it will lead with the non-condensing group. Then, it needs more capacity, it will kick on the condensing group.
Yeah, I think that's a very useful feature because someone doing a retrofit may want to put a lot of hours on the condensing boilers, which would be the new ones, and maintain their non-condensing boilers for operation. But if someone's doing a new plant, they still want to spread the hours out on the different styles of boilers.
Absolutely. And they're all, as soon as you have two different groups, by the way, there's an equal runtime rotation, which is basically respective of the non-condensing group, and again, one which is respective for the condensing group. Okay. Okay.
All right. So the monitoring information that's communicated to the BAS, is that also communicated to the gateway if one is connected?
Indeed it is. Now, if we looked at some of the monitoring information that we have available here, well, the key things here, too, is what we have, which are new items, which are basically communicated. Yes. So such as basically if you look at all of, if you look at the traditional types of information which are communicated on, say, 275 or 274, of all the sensor temperatures, right? So whether it's supply, outdoor, all the pump running times, burner cycles, things like that. So new items, which are, of course, are now used for monitoring, are one, flow rate, because you can hook up a flow sensor. And
is that going to feed back some kind of pressure signal or
what
the flow rate is?
Well, and basically the reason why, we will eventually are going to support a flow meter. Now, right now, you can hook up an analog flow meter, and there are a number of, there's a few manufacturers out there, but the ones we're probably going to support and probably supply as a Techmar product is a Grundfos flow meter. Now, we're looking to support flow rates anywhere from, say, 5 gallons up to, say, 400 gallons per minute. Okay, so that flow meter will do a couple of things. One, of course, it'll measure and display the flow rate. And then if you actually have a return sensor connected, so a system return sensor, now you have a supply and return. So now we actually have a delta T. Okay, so with delta T and plus the flow rate, we now can calculate the energy being consumed and display that in basically therms or kilojoules. Okay, so now once we have that, of course, now we can convey that information onto the gateway. So that's the first thing which we do with the flow sensor. And so the nice thing about the 28402 is that we want to make sure that it's very easy to connect to, and from a contractor standpoint, they don't require any extra parts such as a power supply. So the control provides power and takes a feedback signal from the flow meter. Okay, and yeah, so that's the first thing. Then we can also use, and this is kind of nice for whether it's a ECM pump, because let's just say we're activating, like say, an ECM pump, and that's your system pump, or sorry, your primary pump, right? You know, it could be Alpha pump, it could be a Stratus pump, and we do know that with those, if those are your primary pumps, it's very hard to prove flow with those. You can't take a standard paddle or anything like that, right? Because sometimes you have problems tripping that. So what we can do here is you can actually use a flow sensor, essentially, and set the minimum flow rate which you want to use to prove flow.
What is it?
So you say, okay, well this flow meter handles, let's say, 100 gallons, right? And you say you want to prove flow at, say, 10% of that. So once that flow meter senses 10 gallons per minute, okay, that will be the point where we know we prove flow, so we're good to go.
And you're tying that to system pressure, you said?
No, this has nothing to do with pressure. This is flow.
Okay.
Yeah, we're still talking about the flow sensor.
Okay.
Yeah.
Okay.
Yeah.
Yeah.
Yeah. Sorry?
Would we be able to suggest alternates to or additional meters to Grundfos for you to have compatibility with?
You could, but here's the problem, though, because we do know that there's different types of flow meters, and right now they actually use, like, it's called the flow sensors that basically Grundfos uses. They're a little bit different than the pulse type. They actually have a vane, like a turbine.
Right.
Those ones there.
About another turbine meter.
And who's the manufacturer? Do you know off the top of your head?
Badger. They're located in Wisconsin.
Right. Yeah, those ones there, if they do have those, but they're all self-contained too, right? They actually will calculate, you can hook up sensors to them as well, right? They actually will calculate energy too, I believe.
Yeah, well, they have an inexpensive energy monitor, but the reason
right.
I'm somewhat interested in it is they also have an inexpensive Wi-Fi tie-in or wireless tie-in.
Yeah. The important thing here, the one thing is important, though, as like I mentioned, there's two types of flow meters in the market. Yeah. One, they're pulse type. Yeah. They're actually a digital signal, which we then interpret, right, based on pulses. We're not compatible with that.
Right.
So we're compatible only with the Vortex style, which takes the analog input. So yeah, if they have one, by all means, we could definitely take a look at that and potentially support it. Because right now, we just want to make it easy to set up. So we, based on have all the different models that Grundfos carries, then once they know what model they have, they select their model, and it maps the actual trip points, the rails.
Right.
So, yeah. But by all means, if there's other ones on the marketplace.
Yeah, another thing you might be careful about is you begin to support energy, you're going to have to be a lot more confident of the accuracy and turn down of the meter.
Absolutely.
And I'm not familiar with Grundfos because we're kind of bell and gossip people.
Yeah, and honestly, it's a relatively new type of meter as well, so we have a limited exposure with it. So. Right. Yeah.
Because you're going to have to be careful when you recommend meters. Also, the straight pipe distance.
Yep.
That you're going to be compatible with on either side.
Mm-hmm.
And as I mentioned, rangeability, because, we're talking about boilers, depending on where you're locating it. If you had 4 boilers, like some of your examples, and you're measuring a single flow, you're going to have to turn down potentially to 16 to 1.
Mm-hmm.
And not many meters can do that.
Yeah. No, that's a valid point.
I'll try and look in. If you can give me the model number or whatever of the Grundfos meter, I'll look into it too.
Yeah.
Save you some time.
I can give you that.
Yeah, we have all that information here too, so we'll have to make sure that we provide that documentation to make sure that we deal with this. So. Okay, so then, yeah, so that's one thing, the flow, right, and of course energy. Then we also have a pressure. So now we're basically measuring gauge pressure. Now we are, there are a variety of pressure sensors out in the marketplace, Honeywell, ACI. So we're looking to basically carry one, just to supply one. And we can support, I think, probably 3 or 4 different pressures. 50, 100, 150, 200, and 300, I believe. And you select that model, that range, then you connect it up. It's a 4 to 20 milliamp pressure sensor. So again, we provide power to the sensor and the feedback signal. So we get to basically display gauge pressure. And of course, that then can be communicated over the gateway for display on the web.
One option I'd encourage you to consider there, or other reps to look at, is there are gauges, and thermometers actually, out there which are dual sensing. You have indication at the gauge or at the instrument, and then it also sends a 0 to 10 back. And so that's nice, because lots of times you'll have a system where you can't really look at the Tecmar control, for example, at the same time as look at the gauge.
Yeah.
Or you have a mechanic, who's more familiar with looking at a gauge. Additionally, all of these sensors have something called drift, which is a phenomena where they become inaccurate, and the signal out does. And the calibration method for that drift is often having a mechanical device there. So if you have the mechanical device with that output, you have sort of built-in ability to measure the accuracy of the output.
Yeah, no, we're aware of that too. So, drift is a common issue out there, which we have to try and rectify through, in this case, calibration is one option. But yeah, no, that's something that's noted. I just want to touch base on the question that came in from Bill here regarding the Grundfos, from Owen. The Vortex style sensor from Grundfos. Yeah, so the idea is, again, Nick, these are available from Grundfos, but we'll probably look at carrying maybe a couple models. They do have, it's a plastic body style, and it only goes up to about 104 gallons per minute. They do have a stainless steel version, and they call that the VFI series, and that goes up to over 400 gallons per minute. So we're looking to carry probably 2 models, and then make them available to you guys to purchase from us directly.
Yeah, that plastic one I don't think is rated over 120 degrees F, so you might be careful applying that in a heating system.
Yeah. Yeah, so definitely the stainless steel ones there, a little bit more money, right? And actually quite a bit more on the larger sizes, but they do. We'll probably look at getting those ones. The problem is just availability, because you can only source them from Denmark, so it's kind of availability is a problem. But again, we want to look at least carry a couple models here and just.
If I can find one, the Badger one, to see if it works. For example, it's like an insertion style that comes in through. So you're not looking at a body measuring the flow. Instead, you're inserting, a turbine into the pipe.
Yeah.
And so one thing is that can be hot tapped, which is nice.
Yeah.
But the other thing is that I think it's either a 1/2 or a 3/4 inch insertion. So that might be more flexible.
And just a note there too and this of course confirmed by Owen here as well, but those plastic ones are rated for 100C, right? They are designed for hydronic systems.
Okay.
So, so they are compatible. Okay, the last one here as far as additional information to be monitored is we have a vent temperature. And there's a few things here, like we talked about the flow sensor, we talked about the pressure sensor, and the last one here is vent temperature. Now, we don't yet have these items. Now, one thing is you can purchase, at least the Grundfos, from Grundfos, the flow sensor. You can purchase aftermarket pressure sensors. We are looking to carry some on our own, in our own product line. And the same thing with the vent temperature. we're looking to basically supply a vent sensor, which should basically capture the lower temperature requirements relative to, like, say, a non-condensing boiler plant where the temperature can, be in excess of 900 degrees Fahrenheit. So if we look at basically vent temperature, we're talking about common vent temperature. So we're looking to probably supply a vent sensor which is rated for up to 500 degrees Fahrenheit. Okay, so that would, you could definitely use that on any plant which is homogeneous with condensing boilers. And then we probably will OEM a vent sensor, which probably includes like a transmitter. As you get into higher temperatures, you're going to require either a thermocouple or a an RTD, which then can transmit a 4 to 20 milliamp signal, and that will be able to capture the higher temperature requirements which are experienced in a truly non-condensing boiler plant. So what the vent temperature does, well, one, it does it for, if you look at just say a condensing plant, for example, right? And of course you understand that they all have their own internal vent sensor, which has its own logic, which basically protects the vent from extreme temperatures. So if you choose to, say, control your common vent, you can program a vent maximum. So the idea there is if that vent temperature reaches that vent max, let's just say you program, say, 350 degrees Fahrenheit, and it reaches that, it'll turn off the plant. Okay.
A hard lockout then. It won't just reduce the firing rate. It won't shut them right down.
That's right. It'll shut it right down. And then once it drops to a certain point, then it will turn it back. Then it'll allow the plant to come back on. If you simply just want to monitor and not do any operation, you just don't program a vent max. As soon as you connect up a vent sensor, it's just used for monitoring purposes.
So right now, Jason, are there any options for a vent sensor?
There's no options yet for a vent sensor.
Okay, so the next question I have is, can you go over the combustion airproof function?
So the combustion air, if we just look at just previous controls, I like to compare previous controls because that's what you're familiar with. The 275 and 4, there's a contact which you basically select. Is it, say combustion air or is it alert? And also what the proof is, right? Because in this case you look at 275. If you're doing, say, combustion air control for a damper motor, or you're doing flow proof, well, then you have to assign, well, what do you want to use a proof for, combustion air proof or flow proof? Well, the 284 supports a proof for combustion air and also for flow proof. So if we look at combustion air, we're going to look at the auxiliary relay, which is terminal 4344. That can be defined to be one of two things. One, a combustion air damper motor, okay, or it can be used for a domestic hot water recirculation pump. So in the case of combustion air, the operation is basically the same as with existing products, such that we will turn on that contact and prior to boiler operation. But once you turn it on, if you have a proof selected, then we'll have to receive that proof before we allow the boiler plant to be staged on. Okay. So that operation is consistent with existing products. Okay.
I only have one more question here, and that is asking if you can go over the ways that we can prove primary pump flow.
Yeah, and that's, again, if you look at other products, if you have a pressure switch, flow switch, and typically if you look at a boiler, like within the boiler itself, those are typically flow switches, paddles, right? We're talking about primary flow, right? So you're going to probably buy an aftermarket switch, and paddles aren't the most reliable. So most commonly we've seen our current sensing devices, or you can use a pressure switch if you wish. But those are the most common. We've seen that typically current sensing devices or current sensing switches are typical for proving flow out in the primary loop. And of course, as I mentioned too, if you want to use the flow sensor, and there's a picture of the flow sensor connected up to terminals 13, 14, 15. So you can use that flow sensor to again to display flow and of course prove flow by setting that lower rail based on the full flow of that flow switch. That is a flow which you're going to use to prove flow.
And then in that case, you could use the combustion air damper terminals for a combustion air damper too, right?
Yeah, well, even regardless, right? Let's just say, again, the nice thing about this with this control is there's a separate input, right, for flow. So you could, theoretically, if you look at terminals 1, 2, 3, and 4, right, we have a dedicated terminal for flow proof. So let's just say you just have a standard, let's just say you have a half horsepower pump out in your primary loop, and you just want to use a current sensing device to prove flow, right? So you wire the current sensing switch into 1, 2. And you also want to do a combustion air. So you power a combustion air louver motor out of 4344, then you wire back the end switch from the motor into 3, 4.
Okay.
Yeah.
So those are all of our prepared questions. Do any of you have any live questions for Jason?
So let me ask you a question. Any of you guys have actually on the phone call right now have know of an installed job which has the 284? Anyone?
Not me.
No?
No.
Okay.
We've got one out, but I haven't gotten any feedback on it as of yet.
Okay. Okay.
It was on Lochinvar boilers, and it was because they don't have a BACnet compatible control.
Right.
We have a local controls distributor who's very interested in integrating it into his boiler control panels that he does, custom boiler control panels.
Right, right.
Because, well, primarily because if the BAS goes down, they still have boiler control. And so many other controls, or boiler-centric controls have that problem.
Yeah.
So it's, we think it's going to be very successful. It's just going to take a little bit of time to get it specified and get it out there.
Yeah, absolutely. Now, one thing we didn't talk about is the question here as well. If you look at, there's a new feature on this which is conducive for boilers which only operate based on a set point temperature, specifically with Viessmann. And for example, on the Vitodens 100, 200, right? We can tie in. So typically you can only use like say a Tecmar 400 series product, and where it uses the Tecmar stager function, so it outputs a 0 to 10 volt DC signal, and it's mapped to the Viessmann temperature range. But we've never had the capability to control multiple units. Granted, I do know that people have installed 275s, but it's not intended to operate that type of signal. So this 284 has one of the selections for the boiler type is EMS1 for just a Tecmar temperature range, which goes from 50 to 210. Then we have EMS2 for the Viessmann specific boiler. So now we can operate multiple Viessmann Vitodens boilers where it outputs a target temperature. Furthermore, we can actually operate, again, mixed plants, right? You can have like a single stage and a 2-stage boiler, say a Lochinvar Knight and say a Viessmann Vitodens. So now you're combining different types of boilers, not just condensing, non-condensing, but of course different types of gas trains. So again, you may have a modulating target temperature boiler, such as a Vitodens, with a direct drive capable control, such as the Lochinvar Sync, and then just a standard conventional 2-stage boiler, copper fin 2 Lochinvar, or even a single stage cast iron. So you have a myriad of applications. It's very flexible how you can operate this plant. And from a wiring standpoint, even like setup standpoint, if you look at the terminals, if you want to go back to that, Elizabeth, this control can support, you don't define the relays, right? So basically you have 4 boiler banks, right? You have boiler 1, 51 to 56, that's your boiler bank 1. You basically select through software. Well, is boiler 1, is it single stage? Is it 2-stage? Is it modulating direct drive, or is it modulating target temperature, which is EMS1, or specifically for Viessmann Vitodens, which is EMS2? So you select that per boiler. So it's very flexible. Again, you can have, theoretically, if you could have up to 4 two-stage boilers, or a combination of single-stage, two-stage with modulating. And it has a dedicated boiler pump per boiler. Okay. Any questions which may have you're thinking about while this presentation was occurring, or anything else that we can help you with? Anyone?
Not at the moment.
Okay.
I did want to say I like the format of having a live follow-up chat based on previously given and then also web accessible webinars. I like that way of doing it.
Yeah, this is the kind of the first time we've done that, which is kind of nice. You got to think too. Once we display a new product, especially with the capability of the 284, right? We go through a lot of detail. Maybe there's not enough time for questions, or you might think of something after the fact, so you want clarification. So definitely a follow-up Q&A is definitely, I think, worthwhile.
Yes.
So we'll probably maintain that format moving forward too. So
certainly pass
I thought of another way. You have these rep questions coming in on a separate email, essentially. It might be interesting to maintain that email just for general questions for reps when they viewed the various presentations that you're making available online. I think that might be an idea.
Yeah, we do include the learn@techmarcontrols.com email address at the end of the webinars. And I myself check that email every day to see if any questions have come in.
Okay, great.
So feel free whenever you're watching one of the webinars to send us a question.
Okay, good. Good to know.
Yeah.
Very nice.
Okay, well, if there's no other questions, we definitely appreciate your time. And by all means, if there's any questions after the fact, you can submit your questions, whether, Techmar Customer Service or even to the Techmar Learn for that matter, and we'll have someone follow up.
Great. Well, thanks again. Have a good afternoon.
Thanks, guys.
Thanks
Okay,
very
all right.
much.
Thanks, you guys.
Okay. Bye-bye.
Bye-bye.